question 7 and 7a asks, determine the exact measure of each unknown side if sine x is 1 over 2. So sine is opposite over hypotenuse. So I know that this is 1 because this is the opposite of sine x, and this is 2. And then I use Pythagoras theorem to find this side, the bottom. So it'll be a squared plus b squared equals c squared, but I flipped it to find a squared, and then you plug in all the numbers. And then what else did I do? I'm sorry. Oh, and then I use sine law to determine side C because hold on. Actually, scratch that. After you find all the sides of this triangle, I know that this angle is 90, this angle is 45, so this angle is 45, which means that if these are both 45, then B, this like small a to b, should also be 1 because they're equal. And then you can use you can use Pythagoras theorem from 1 over here and 1 over here. Do a squared plus b squared to find c squared, which is the square root of 2. So that's how I got 1.41 centimeters. And then you can just add these together to get 2.7321 for the distance of A to C. I don't know why I did this. This was the long way. And then it asks to determine the exact values of the primary trigonometric ratios for angle A and angle DBC. And then, so the primary trigonometric ratios are sine, cosine, and tangent. And then
you gotta do it on the computer.
Okay.
You can use your hand.
And so for angle A, sine 45 is opposite over hypotenuse, so it's 1 over 1.41. And then cosine is also 40. I use the same angle. I said cosine is also 45, but then it'd be adjacent over hypotenuse, which is 1 over 1.41 again, because these sides are both 1. And then tan would also be 45, but it's 1 over 1 because it's opposite over adjacent. And then for angle DBC, which is 60, I found angle 60 by subtracting 180 from 90 and 30 degrees. And then sine 60 is opposite over hypotenuse, so it would be 1.7321 over 2. Cos 60 would be adjacent over hypotenuse, so it would be 1 over 2. And then tan 60 would be opposite over adjacent, so it's 1.7321 over 1.
Okay, great. The only thing I would say is, do you know what it means when it says exact measures and exact values?
No.
Okay, all the process is correct. The only thing is, you know how, look at the top where you have like c equals root 2, and then you wrote c equals 1.41. Root 2 is exact value.
Oh.
So yeah, because decimal is always a rounded value, right? It's not the exact measure. Whenever it says exact measure, just leave it in the root form.
So this would be 1 over root.
Yes. Yeah. But all your process is right. So it's just this one thing. Okay? Good job.